Static electricity from carpets can indeed damage sensitive electronic equipment. It's a known issue, especially in dry environments. Walking on a carpet generates static electricity through friction. The electrical charge accumulates and discharges upon touching conductive surfaces like metal or electronic equipment. A strong discharge sends a current surge through the circuitry, damaging components, also known as electrostatic discharge or ESD. The arc when touching conference call telephones or plugging in laptop computers strongly suggests static electricity was the culprit. The burned out parts indicate a strong ESD surge. Even if voltage and grounding seem fine, intermittent grounding issues or inadequate ESD protection might exist. To prevent static electricity damage in conference centers, firstly, install anti-static carpets or use anti-static carpet sprays. Secondly, ensure adequate grounding of all equipment. Thirdly, use ESD protected outlets or power strips. Fourthly, maintain humidity levels above 30% to reduce static buildup. Fifthly, discharge before touching electronic equipment by touching a grounded metal surface. Sixthly, use anti-static wrist straps or mats when handling sensitive equipment. Additional considerations should be followed. During dry seasons, take extra precautions because static electricity is more prevalent. Avoid wearing shoes that generate static electricity, such as leather-soled shoes. Consider installing an ESD detection and suppression system to monitor and control static discharge. Static electricity is generated by the triboelectric effect, which is the buildup of electrical charge through contact-induced separation or removal of electrons from a material. Materials have different affinities for electrons. When two materials are rubbed together, one material gains electrons and becomes negatively charged, while the other loses electrons and becomes positively charged. The extent of charge buildup depends on several factors, including the materials involved, the surface area of contact, the pressure applied, and the speed of rubbing. Carpets are common generators of static electricity. Synthetic fibers like nylon and polyester have a high propensity to generate static charges compared to natural fibers like cotton or wool. Walking on a carpet causes repeated contact and separation between your shoes and the carpet fibers, leading to a significant buildup of static electricity. The human body acts as a conductor, accumulating the static charge generated by walking on the carpet. This charge can reach several thousand volts, especially in dry conditions. When the charged person touches a grounded object, such as electronic equipment, the accumulated charge rapidly discharges, resulting in an ESD event. The magnitude of the ESD event depends on the amount of charge accumulated and the speed of discharge. Sensitive electronic components are susceptible to damage from even relatively low voltage ESD events, often as little as 100 volts. The effects of ESD on electronic equipment can range from temporary malfunction to permanent damage. ESD can cause latent defects in components, which may not be immediately apparent, but can lead to premature failure over time. ESD can also cause catastrophic failure, such as burnout of integrated circuits or dielectric breakdown of capacitors. In conference centers, sensitive electronic equipment, such as audiovisual systems, telecommunications equipment, and computer systems, are at risk from ESD damage. These devices contain numerous integrated circuits and other sensitive components that can be damaged by ESD events. Grounding involves providing a low resistance path for electrical current to flow back to the source. Proper grounding helps to equalize the electrical potential between different objects and reduces the risk of ESD. All electrical equipment should be properly grounded, according to applicable electrical codes. Grounding can be achieved through various means, such as connecting equipment to grounded metal chassis or using ground wires. Bonding involves connecting two or more conductive objects together to equalize their electrical potential. Bonding helps to prevent the buildup of static charges on objects that are not directly grounded. Bonding can be achieved by connecting objects together with conductive straps or wires. Humidity plays a significant role in static electricity generation and dissipation. High humidity levels increase the conductivity of air, which helps to dissipate static charges more quickly. Maintaining a relative humidity level above 30% can significantly reduce the risk of ESD events. Humidity can be increased through various means, such as using humidifiers or air conditioning systems with humidity control features. Anti-static materials are designed to reduce the generation or accumulation of static electricity. Anti-static carpets are made from materials that have a low propensity to generate static charges. Anti-static sprays can be applied to carpets and other surfaces to reduce their static charge generation properties. Anti-static wrist straps and mats provide a conductive path for static charges to dissipate from the body to ground. ESD-protected outlets and power strips contain surge suppression circuitry that helps to protect equipment from ESD events. These devices typically use metal oxide varistors, or MOVs, to divert excess current away from sensitive components. ESD detection and suppression systems monitor static discharge in the room and take corrective actions to prevent ESD events. These systems typically use sensors to detect static charges and activate suppression devices, such as air ionizers or grounding systems. Air ionizers generate positive and negative ions in the air, which help to neutralize static charges. Air ionizers can be used to reduce the buildup of static electricity on surfaces and in the air. Regular maintenance of electrical equipment is essential to ensure proper grounding and bonding. This includes checking ground connections, inspecting for damaged wires, and cleaning equipment to remove dust and debris. Training personnel on ESD awareness and prevention practices is crucial to minimize the risk of ESD damage. This includes educating employees on the causes and effects of ESD, proper handling procedures for sensitive equipment, and the use of anti-static measures. Conduct periodic ESD audits to identify potential hazards and assess the effectiveness of prevention measures. This includes evaluating grounding and bonding systems, measuring humidity levels, and inspecting for static generating materials. Follow industry standards and best practices for ESD control, such as those established by the ESD Association. These standards provide guidance on implementing effective ESD control programs and selecting appropriate anti-static materials and equipment. Conduct research and stay informed about the latest advancements in ESD control technology. This includes attending industry conferences, reading technical publications, and consulting with ESD experts. By implementing a comprehensive ESD control program, organizations can significantly reduce the risk of damage to sensitive electronic equipment and improve the reliability of their operations. Static electricity is more problematic in climates where the humidity is low, especially during the winter months when heating systems further dry out the air. The amount of static charge generated is also affected by the type of clothing worn. Synthetic fabrics like nylon and polyester tend to generate more static than natural fibers like cotton and wool. Footwear plays a significant role in static charge generation. Rubber sole shoes insulate the body from the ground, allowing static charges to accumulate. Leather-soled shoes can also generate static electricity, especially on certain types of flooring. The design of electronic equipment can affect its susceptibility to ESD damage. Equipment with poorly shielded circuits or inadequate grounding is more vulnerable to ESD events. The location of electronic equipment can also impact its risk of ESD damage. Equipment located near windows or doorways may be more exposed to ESD events due to drafts or changes in humidity. The type of work being performed can also increase the risk of ESD damage. Activities that involve handling electronic components or working with static generating materials, such as plastics, can increase the likelihood of ESD events. When selecting anti-static carpets, consider the material, construction, and resistance to wear. Carpets made from low static generating materials, such as nylon with carbon fibers, are preferable. The carpet should also be durable and easy to clean. When using anti-static sprays, follow the manufacturer's instructions carefully. Apply the spray evenly to the carpet and allow it to dry completely before use. Reapply the spray periodically, as needed, to maintain its anti-static properties. Ensure that anti-static wrist straps are properly fitted and grounded. The wrist strap should make good contact with the skin to provide a conductive path for static charges to dissipate. Check the wrist strap regularly to ensure that it is functioning properly. Use ESD-protected outlets and power strips that are certified to meet industry standards. These devices should provide adequate surge suppression to protect equipment from ESD events. Regularly inspect ESD detection and suppression systems to ensure that they are functioning properly. Check the sensors, suppression devices, and control panels to ensure that they are in good working order. Implement a system for tracking and documenting ESD events. This can help to identify trends and patterns that can be used to improve ESD control measures. Investigate the root cause of ESD events to determine the factors that contributed to the event. This can help to identify areas where ESD control measures need to be improved. Share information about ESD events with employees to raise awareness and promote a culture of ESD prevention. Provide employees with training on how to report ESD events and what to do in the event of an ESD event. Regularly review and update ESD control procedures to ensure that they are effective and up to date. This should include incorporating new technologies and best practices as they become available. Collaborate with ESD experts to develop and implement effective ESD control programs. ESD experts can provide valuable guidance on selecting appropriate anti-static materials, designing ESD-protected work areas, and training personnel on ESD prevention practices. Conduct regular self-assessments to evaluate the effectiveness of ESD control programs. This can help to identify areas where improvements can be made and ensure that the program is meeting its objectives. By implementing a comprehensive and well-maintained ESD control program, organizations can protect the sensitive electronic equipment from damage and improve the reliability of their operations. Static electricity can cause a range of problems beyond damaging electronic equipment. It can also cause discomfort to people, such as shocks when touching metal objects. Static electricity can also attract dust and dirt, which can contaminate clean rooms and other sensitive environments. In some cases, static electricity can even cause explosions or fires. For example, static electricity can ignite flammable liquids or gases. Therefore, it is important to take precautions to prevent static electricity buildup in all types of environments, not just those where sensitive electronic equipment is present. The cost of implementing an ESD control program can vary depending on the size and complexity of the organization. However, the cost of not implementing an ESD control program can be much higher, especially if sensitive electronic equipment is damaged or destroyed. A well-designed and implemented ESD control program can pay for itself many times over in terms of reduced equipment damage, improved reliability, and increased productivity.